A polynomial is an expression with at least one term consisting of constants and or variables with positive integer exponents. That sounds like a lot, but when you break it down, when they talk about constants, it just means we're looking at numbers, like 3, -2, 15. Those are examples of constants. A variable are things like x, y, a's, b's. Positive integer exponents, those are numbers 1, 2, 3, 4, 5, and so on. So positive integers. Some polynomial expressions, 2xy minus 3a, there's two terms in that expression. 2xy is the first term, and -3a is the second term. We also have 4x squared plus 2x minus 8. That's a polynomial expression. There's three terms. 4x squared is the first term, 2x is the second term, and then -8 is the third term. In the next one, 2a to the third times b minus 7a b to the fifth. There's only two terms there. Don't confuse terms with the exponents or how many variables there are. So there's two terms. There are two variables. A and b are both variables, and then you have different exponents on them. We have some common polynomial functions, and we've actually been working with these throughout the course without actually doing the definition of what a polynomial is. So we've worked with constant functions before, like y equals 5. Linear functions, y equals ax plus b, like y equals 3x minus 2. That's a linear polynomial. And then we've also looked at quadratic functions. We've graphed those before. And then we have cubics. And what you might notice is as you go down that list, notice that we keep on adding another term to the expression. So linear, you have ax to the first. Quadratic is an ax squared. And then cubic is ax to the third. So you keep on bumping up the exponent by 1 as you go down that list. So some other definitions that you need to know: the degree of a term. It's the exponent of its variable. So if we look at y equals x to the third minus 4x, the degree of the first term is 3. The degree of the second term is 1, because that's 4x to the first there. The degree of a polynomial, it's the highest degree of all its terms. So with that same polynomial, the degree of that polynomial would be 3, because 3 is the largest exponent. And then standard form, it's when the terms of a polynomial are written in descending order of degrees. So each of these polynomials is written in standard polynomial form, because we start with the largest exponent first, and then the next largest, and the next largest, and so on. So write two examples of an expression that is not a polynomial. So a polynomial has constants and variables with positive integer exponents. So something that's not a polynomial would be something that does not have positive integer exponents. So an example of that would be like x to the -2. That's a negative integer exponent. Now, I don't expect you to know this at this point, but x to the -2 is really 1 over x squared. And the reason I'm bringing this up is because if you have an x in the denominator, that means you're not going to have a polynomial. Another example, well, if we don't have a negative exponent, what about if we have a fraction? Like x to the 1/2. And again, I don't expect you to know this at this point, but x to the 1/2 is really a square root of x. So those will be examples of expressions that are not polynomials, because they don't have positive integer exponents. Okay, next thing we look at is combining like terms. And note that we can only add or subtract like terms. And again, we've been doing this throughout the course without really defining it as we're adding polynomials. We've just been doing the operations assuming that we knew what we were doing. Like terms have exactly the same variable and exponent. So for example, we know that 3x plus 5x equals 8x because 3x and 5x are like terms. However, we may not simplify 3x plus 5 because 3x and 5 are not like terms. So you can't actually add those together and get 8x. And the idea there is, with 3x plus 5x, you think about if you have 3 of something and add 5 of that same something, you have 8 of that something. So for example, if you have 3 pens plus 5 pens, you can add those together to get 8 pens. But if you have 3 pens and 5, you can't actually add those together because we don't know that that's 5 pens. I know that's kind of a silly example, but that's how I explain it. Okay, so in the next part there's several different for you to try. And again, there's nothing new here. You've been doing this throughout the semester, especially when you solve equations. So if you have 15h minus 21h, you combine those together to get negative 6h. Okay, notice that we don't do anything with the exponent. The exponent stays the same. So take a few minutes and try the rest of those in that little block, and then we'll move on to the next block of multiplying terms. Okay, so pause the video, and I'm going to show the answers. Okay, the last thing we look at is multiplying like terms. I'm sorry, multiplying terms, not like terms. Okay, so we can always multiply terms together. We've been doing this throughout the course also, maybe without even realizing it. So when we have the term 5x, really what we're doing is multiplying 5 and x. So if we want to take 6g and multiply it by 5g, so 6 times 5 is 30, and then g times g is g squared. And notice how this is different than when you add polynomials, is that now you really have to pay attention to the exponent. And imagine if g was a number. So just suppose g was 3. You'd have a 6 times 3, and then 5 times 3. So when you do 6 times 5, you get 30. And then 3 times 3 would be 3 squared. So g times g is g squared. Okay, so you end up with 30g squared. Okay, in number 11, I'll just look at that one because it's right here. Again, pay attention to the exponents. We have negative 4x to the 5th times negative 5x to the 3rd. So negative 4 times negative 5 is positive 20. And then x to the 5th times x to the 3rd is x to the 8th. And if you want to look at it this way, think about when you multiply a variable by itself. So when you do x times x, that's x squared. If you take x to the 5th, isn't that really x times itself 5 times? So 1, 2, 3, 4, 5 times. And then we have 3 more. So another x, x, x. So how many x's do you have here? You have 8 of them. So you multiply x by itself 8 times. So that shows up as x to the 8th. So take a minute and pause the video and try the rest of those, and I'll show the answers.